And so the notion of concatenation, here's a basic example. Suppose I have two data frames. So I have my data frame AB, or I have columns AB, and I have row values 0, 1, 2, and then I have the corresponding values in this data frame, and I want to concatenate, or I want to add that to the second data frame. What does the answer look like? What should the answer look like? And this whole notion of concatenation basically says there are several different ways that you can look at this type of simple addition. Note in this case, we have common indexes, but different columns. And then if we look at the second case, we have, in this case, well, I guess we have the same common indexes, but we also have the same column. So the question is, in general, what is the interpretation of this in Pandas? And so that is in this notebook. The material that from the Vanderplas notebook is in this 3.1 concatenating, appending, and joining. And as I mentioned before, and we'll mention again when we get there, the part about joining is not part of the test. So joining is where we stop. We will pick up and talk about joining on Thursday, but it's not part of the material that we're going to cover for the test. So here are the two data frames that we have. These are the same two data frames that we saw in the PowerPoint, where I have 3 rows indexed by integers, and I have 2 different columns, A, B, and C, D. And if we just apply the concatenate, which stands for concatenation function, you can see what happened. Is it basically just added different copies of all of the values, right? So it extended my row index twice. So it used all of the row indices from A, all of the row indices from B, even though they're the same, and then created an index with all of those values. And then it took all of the columns from A and all of the columns from B and appended those. And so when we create a data frame that has all of those row values and all of those column values, obviously in the A portion, or the portion that came from A, we have all of these nans, all of the knotted numbers, because it didn't exist in the initial data frame. Similarly, for the one from B, we have all of these nans. And so when we use the notion of concatenation to add these two together, essentially, or concatenate these values, the default behavior basically just says combine these, keeping all of the indices intact. Okay? Now, of course, when we do that, if I use the standard dictionary type indexing, so for example, I use the location, loc, remember, uses the explicit index, and I say, show me location 1, well, now I have 2 rows. So I have this row and I have this row, because they both have that same index values. Whereas if I use iloc, the implicit location, they don't, because the implicit location is only going to give me row with implicit index 1. So we start with 0, remember, 0 based and 1 based, and so we get this single row value. Okay? So, a couple of things to note here. First of all, indices don't have to be unique. Well, this is confusing, right? This is often confusing. Indices don't have to be unique. These are different index values, or we're stored differently. And so when I have that situation, then you have to decide, well, what does that actually mean? What do I want to happen when I have that? So if I pull these out using the explicit index, I get them both. The implicit index, I don't. Okay? Also, we can try that, or we can detect cases where we have multiple values of the same index by using the verify integrity parameter here. And so in my comment here, I say that we haven't talked about exception handling, but essentially all exception handling does is it catches exceptions, so it doesn't print that long error message. So if I execute this code, what's happening is it's saying, hey, he wants to concatenate these together and verify the integrity of the index. That's going to fail, right? That line would fail, and so the try except basically just doesn't let it print all the errors and lets me print the error in a nice way. And that's exactly what you see right here. Is it just said, hey, there's an error here. I don't want to print all the stuff that Python by default prints, but here's the basic error that got printed. Okay, so if for whatever reason you want to concatenate, and you want to check and make sure that you don't have multiple instances of the same index value, the verify integrity parameter will do that. Another thing that we could do is we could use the ignore index. So if I use the ignore index, basically what I'm saying is, hey, I don't care about the original index, right? So I have the index 0, 1, 2 for A, and I have the index 0, 1, 2 for B. So when I concatenate those, I end up with what we saw above, which is 0, 1, 2, 0, 1, 2 is my index. But if I ignore that index, I don't care about it. It just discards it. And now we end up with the situation where the explicit reference, the explicit index, matches the implicit reference. So it's just the range of integers from 0 to 6, step 1. So it matches exactly the implicit. So if you don't want to have multiple values, you can use the verify to detect a problem. If you can just ignore the indices, then just use the ignore index parameter, and it will create a new index. Okay? I can also specify that concatenation happens along a particular axis. So you remember when we talked about NumPy and we talked about Pandas, the notion of an axis. So you have axis 0, you have axis 1. Axis 0 is what we think about as rows. Axis 1 is what we think about as column. So in this case, if I'm saying I want to use axis 1, so I want to concatenate along axis 1, oops, didn't mean to do that. Let me execute that. Now you can see different behavior. So now what it's doing is it's saying, okay, he wants to concatenate along the column axis. I know that the row indices are the same, 0, 1, 2, so it's just going to take and kind of squish these two together, which if you look back to our first PowerPoint, right, you look at the first PowerPoint, you look at this, your first inclination was probably exactly that. Is that when you look at this, you say, hey, I need to make a data frame that has 3 rows and 4 columns, because when you look at this, you say, hey, these two indices are the same. These two are different, so we just want to create that 3 row 4 column. Okay, and so when we do that, when we specify the axis, that is exactly what it does. Okay. So a couple more examples of doing that similar stuff. We have the A and B, 0, 1, and 2, and C. So if I concatenate A and C here, right? And now we got the exact same behavior that we saw before, except now my A and B aren't replicated, because by default, the concatenation happens on axis 0. And so if I now do my ignore index, now we see the same kind of thing where we have that index ignoring. I can also specify axis 1. So now we're doing the AB and ignoring the row values. I can extract B. In this case, again, we have 2 B columns. So we can ignore the index, and it will drop the AB, and give me the corresponding index value. And so the bottom line here is that the concatenation operation will take 2 data frames and do a concatenation operation. And by using the index value or the ignore index, you can create a new index and guarantee that they're unique. You can specify the axis on which you'd like the concatenation to occur. Okay? And so you can go back and see from our example here, if we do the concatenation with no other parameters, it's going to end up with the 0, 1, 2, 0, 1, 2. So it's going to add these essentially this way, and then add the 2 columns together. And if we specify axis 1, it will recognize that this index and this index are the same, and it will just add the 4 columns to the resulting data frame.